Okay, Puneet, let's take a look at this question. You've asked me this question a couple of times. Let's see how to answer this. So, let's read off the question. A uniform rod of mass m and length l rotates in a horizontal plane with an angular velocity omega about a vertical axis passing through one end. The tension in the rod at a distance x from the axis is what? And you're given a couple of options. Yeah, so let's try and see what it could be. And so first step, as you know, is to analyze what's going on. All right, so here's our rod and here's our rod. Okay, kind of thing. It's rotating about this axis over here. We need to find the tension at this point, which is at a distance of x, and the length of the rod itself is L. Yeah, this is what you're given. So I guess this is a rod is a, you could assume it's a one-dimensional object, and therefore you need to assume that the mass per unit length is constant. So let's say sigma is equal to the mass per unit length. Yeah. Now, what you need to understand is if you cut, this is completely equivalent, okay, to if you were to cut this rod here, and you could replace this piece with another mass. Yeah, I'm going to draw it in red over here. Okay, this mass m. Now the catch here is this. So essentially I'm telling you this just to explain to you that if you were to cut it, you need to see that it's the tension that's providing the centripetal force for this block, this piece of the block, yeah, or this piece of the rod to move in circular motion, right? And the tension is at this point x. That's the important point to note. So the question really reduces to answering this question, answering what is the centripetal force required at this point x. Obviously, let's you know the formula for centripetal force. That's given by let's say the tension would be equal to m prime v squared by r. Yeah, where m prime is the mass that's moving, v square is the linear velocity, yeah, and r is the radius with which it's moving. And the trick really lies here. What is the centripetal force? So let's take each one. Let's take each one step at a time. First, let's rewrite this formula. T equals mv squared by r, and if I write omega equal to v by r, I can write this as m v squared by r squared. Yeah, sorry, that's a squared into r, which is equal to m omega squared r. Okay. Now the trick really lies in figuring out what is m and what is r. Okay. Let's work on m first. Now this, so let me just take another color here. We are worried about this little segment of the rod. Okay. What's its mass? And that should be quite straightforward. That mass is going to be given, so we're going to call it m is, or rather m, let's just call this all m prime, yeah, just to distinguish it from m, which is the mass of the entire rod itself. So m with m prime, sorry, which is the length of the green piece, is nothing but sigma times the length of the rod, which is L minus x, which is equal to m by L into L minus x, which I can write as equal to m times 1 minus x by L. This should be straightforward. Okay. Now omega is omega. That's every point on the rod is going to have the same angular velocity, so we don't need to worry about this. Finally, we've got to worry about r. Now the question is this little piece here, yeah, this piece here. The center of mass is located at the middle of that piece, and therefore the radius, effective radius, yeah, if you had to reduce this entire piece to a point mass, which would act at the middle over there, is actually this x plus this halfway distance, yeah, L minus x by 2. Okay, so you would have to say that R itself in this case is equal to x plus L minus x by 2, which is equal to, in effect, L plus x by 2, yeah, or it's equal to 1 by 2 or L by 2 into 1 plus x by L. You've computed m prime, you've got R, and you've got omega is omega. Plug in these values into this tension equation, yeah, and therefore you get T equals m prime, which is m times 1 minus x by L, yeah, and that's one, sorry, something's wrong with my pen, times omega squared times R, which is L by 2 into 1 plus x by L. If you simplify this, you will get this equal to m omega squared L by 2 into 1 minus x squared by L squared, which is the correct option given. If you still don't understand it, do let me know.